In this lesson, we're going to have some example problems and then look at how momentum and impulse are related to each other through graphs. So let's get started. First, we have a 52 kilogram woman running 1.5 kilometers in 5 minutes, and we want to know her momentum. So we know she has a mass of 52 kilograms. We are told how far she runs and in what amount of time. You should know by now that distance should be measured in meters, not kilometers, and time should be measured in seconds, not minutes. So let's go ahead and change those before we do any calculations. I'm going to set up my conversion factor. There are 10 to the third, or 1,000 meters for every 1 kilometer, and I want kilometers on the bottom so that those cancel. And this gives me a distance of 1.5 times 10 to the third meters. And then for seconds, there are 60 seconds for every 1 minute. And again, the minutes are going to go on the bottom so that they cancel. And this gives us 300 seconds. Now, in order to get momentum, we know that momentum is going to be mass times velocity, and there wasn't a direction indicated, so I'm going to leave off the vector notation for right now, and we'll just look at the scalar, or the magnitude of the momentum. Now, we have a mass, but we need a velocity. If you think back to chapter 1 or 2, we could calculate the velocity or the speed by doing distance over time. And now that we have the correct units for each of those, I'm going to go ahead and plug in my 1.5 times 10 to the third meters over 300 seconds and find out what that speed is. You should have come up with 5 meters per second. Now that we have both the mass and the velocity, I'm going to plug those in and find out what our momentum is. Hopefully you get an answer of approximately 260 kilograms times meters over seconds for the magnitude of that momentum. Our second example is a little bit more involved, so I'm going to go ahead and identify all of the variables. First, we have a stationary golf ball, so this lets us know that we start out with an initial velocity of 0, 60 grams for the mass, and we do want to change that to kilograms. And it leaves the golf club with a velocity of 73 meters per second, so we have a final value. And we're also told a force. Now don't worry that it says an average force, that just means how much force is applied over the time that it took the golf ball to go from 0 to 73 meters per second. So we're just going to label that as our force. First, we are looking for a time, and then we're going to be asked to find the impulse. For this problem, you want to think back to that mix and match equation. Momentum is not mentioned anywhere in the problem, but impulse is, and we can recall from our notes earlier that impulse can be equal to mass times a change in velocity, or a force times a time, or a change in momentum. Now in this first problem, we know that we are looking for a time, so we're definitely going to be using this part of our equation. So I'm going to go ahead and say Ft equals. And then now we want to look at the other variables that are given. We've got a mass and a change in velocity that we can calculate, so that lets us know that we're going to use this part of the equation as our other half. And we will create our equation, and it looks like this. Now we can solve for the time. So I'm going to divide both sides by the force, and now we can plug our numbers in. Notice I plugged in the kilograms version of our mass. For our delta V, remember for a change you subtract final minus initial, so I did 73 minus 0, and then divide it by our force. And when you type that in your calculator, you should get a value for the time of 1.46 times 10 to the negative fourth seconds. And I know that's a really, really small number. However, if you think about striking a golf ball, the club is actually in contact with the ball for a fraction of a second, so it makes sense that this is such a small number. I'm going to go ahead and erase the screen so we can do part B. Okay, now we are looking for the impulse. We can use any of these three things to find our impulse. We found a time in part A and we were given a force, so we could multiply that answer times our force and get that. Or we can calculate the initial and the final momentum because we have a mass and a final velocity and an initial velocity. Or we can simply plug in the mass times the change in velocity from the given values. I'm going to do this option, but feel free to try any of those three that you would like. So I simply plugged in my mass in kilograms, and again I subtracted the final velocity minus the initial velocity. And this gives me an impulse value of 4.38, or you could say 4.4, and then kilograms times meters over seconds. And I did want to show you real quickly that if we had done the force times the time option, that we would get the same answer. So I'm going to go ahead and write that up for you. So if you take a look, we can plug in our force times the answer we got in part A for the time, and we do get the same magnitude for the impulse. There is a slight difference in the units because I multiplied newtons and seconds together. However, if I were to substitute in for a newton, I would reduce that down to a kilogram meter over second. So those are the same answer. You can use either version of those units. Whichever one's easier for you to remember is fine. Our third example is going to use the mix and match impulse formula again. So first, let's write down all of our givens. Okay, notice we do have some directions indicated with the negative sign. So we have a negative 475 newtons. It's used to stop an object moving at 160 meters per second. So we are going to have a final velocity of 0 because it's coming to a stop. And then we're told that it takes 19.8 seconds to make the object come to a stop. And we're looking for the mass. So let's look at that equation with several things that we can set equal to each other. So take a moment and see if you can figure out which two of these four parts we would set equal in order to come up with our equation to solve this problem. I hope you saw that we would be using the two middle sections. And since I'm looking for the mass, I'm simply going to divide both sides by the change in velocity and plug in my numbers.